All right, thank you and welcome. Good morning, good afternoon, good evening, good everything. My name is Juan, and today I have a very, let's call it light and even fun presentation, which I'm calling Getting Better at Pokemon Using Data, Python, and ChatGPT. Now, once again, my name is Juan, and I work as a software engineer for the trust and safety team at BT. However, for today, I would like to remove this title and just call myself a fan of Python, data, and of course, Pokemon. So please follow me. Now, I feel like I need to start this talk by saying how much I love the Pokemon Trading Card game. It's fun, it's cool, I like the competition, and of course, it's good to making friends. I just moved here to this city around 2 years ago, and I noticed there's like a huge Pokemon trading card community. So I went in, and now I have millions of Poke friends. However, as much as I like the game, I need to admit that I'm very bad at it. And as you can see here, those are some pictures of myself playing the game, and I do not look happy at all. So, in an attempt to get better and learn from my mistake, I started to use a resource that we all here like, or we should, right? And that's data. So, I started to collect data on my games with the goal of analyzing them in the future using a mix of tools that include Python, yay, R, JavaScript, Google Sheets, and ChatGPT. Yes, a lot of things. But have I gotten any better? I don't really know. Please, you be the judge. However, at least I have a very cool presentation to share with all of you. Now, this is the agenda for today. After this short introduction, I'm going to present my first of three projects. The first one is called Will I Draw a Battle Baby Pass? The second one is I'm going to talk about a data analysis that I did using information that are from 100 matches. And then I'm going to present how I evolved my notebook from the second project into a dashboard in Google Sheet. And then, of course, unfortunately, I need to end my presentation. So follow me. Will I draw a battle baby pass? Parenthesis, all the pictures that you will see here, I did it myself. I'm also an avid photographer, and of course, I like to also take pictures of cards. So please enjoy them. Now, some basic rules, right, before we start. A Pokemon deck has 60 cards. 60 cards here, you see them, 60. At the start of each game, each player draws 7 cards and an additional 6 cards that are the prizes. So once again, 60 minus 7 that you start with, and then you have like another 6. Now, you do not know what are those other 6 cards. They are your prizes. And to get them, you get either 1, 2, or 3 every time you KO an opponent's Pokemon. And of course, the first player to take 6 prizes wins the game. Also, we need to know that at the start of each turn, you draw a card. And now, with this rule in mind, I wanted to know the odds of drawing a Battle Baby Pass in my initial hand and in my initial draw. But what's so special about this card? Right? Why do I want it? Well, this card is very good because it lets you to look for up to 2 basic Pokemons on your deck and then place them onto your bench. And your bench can have a maximum of 5 Pokemon, so having 2 of them and getting them off 1 card is a big deal. However, there's one big catch in this card, and that's that you're only allowed to play it during your first turn. So after the first turn, this card is essentially dead. It's useless. So you want to increase the odds of seeing this card during your first turn. And so I started looking around and reading and trying to find like how can I calculate this. And of course, there are many guys online, but I wanted to do it by myself, right? So I could learn about this. And then I found out something called a hypergeometric distribution. And this one is the one that tells you the likelihood of drawing a specific number of items from a set without putting them back or without replacement. For example, suppose that you have 1 bucket and you have red and green balls. Well, this distribution calculates the chances of picking up a certain number of green balls in a handful of draws. Or in my case, what are the chances of drawing this elusive card from a deck of 60 cards? And now I want to introduce 2 different cases, right? The first one is the probability of getting 1 Battle Baby Pass in my initial hand. And here we have the hypergeometric distribution. We have some sort of binomial coefficients like k choose n multiplied by another one divided by n choose n. And these are the values here. We have that n is the population size. In this case, it's going to be 60 because I have 60 cards on my deck, right? Then I have K, which is the number of successes in population. In this case, it's 4 because my deck has 4 VIP passes. The sample size is 7 because, as I mentioned before, you are going to draw 7 cards in your first hand. And then K here is the number of successes in the sample, which is 1 because I want to at least see 1 card. So I quickly went here, I replaced all the values and I started to do it by hand. But then I realized like, oh, these numbers are quite huge, so I need to use Python. So I went to Python, I did and then voila, this is the number, 33.63%. And yet I never seem to see the card. But now, besides knowing the odds of drawing 1, I also wanted to know the same for 0, 2, 3, or 4 VIP passes. And instead of doing the whole thing, I went to Python, I Googled how to calculate the hypergeometric distribution, and of course, SciPy has this function implemented. So I wrote a very tiny function that calculates the distribution from 0 up to 4. And here in this small comment down there, you can see the answer. So we have 60% of drawing 0 VIP pass, or we have 33% of drawing 1, which is what I showed before, almost 6% of seeing 2, 0.38% of seeing 3, and almost 0% of seeing 4. And that's something that I've never ever seen before. And here we have in a small visualization the same data. I did this using R, and you can see that huge drop from 1 to 2. So if you don't see at least 1, the chances of getting 2 are very, very low. Actually, I have here my deck. Let's see. I just draw 7 cards without seeing them. 1, 2, 3, 4, 5, 6, 7. Do I have it? Let's see. And the answer is, of course, no. I do not have it right here. So I keep telling you, I never see that card. Now, let's suppose that I didn't see any card in my initial hand. And let's also suppose that I don't have one of them in my prices. So what are the probability of getting one in my initial draw? The numbers here, they are almost the same, except by the population size, which is 47, because I have my 60 minus my initial 7 cards, minus the 6 cards I have in my prices. And here the number of the sample size is 1 because I'm just drawing 1 card. And the answer is 8.51. So if I didn't see any in my first one, then at least I have almost 10% of drawing in my first draw. Maybe it's this one that I have here. No, it's not. So as you can see, well, I need a little bit of luck. Now for the second project, and this one I'm calling it what I have learned after tracking 100 matches. And at some point, I decided to track the outcome and details of my Pokemon matches that I have played using an archetype of a deck called Lost Box. Fun fact, why is it called this way? Well, because this type of deck wants you to get as many cards into something called the Lost Zone. I know it's a cool name, because good things happen when you get to 4, 7, and 10. If you want to know, just ask me at the very end. And this is my data set. Pretty straightforward. It has 8 columns and, well, 97 rows, each for one game. We can see that the first one is the time when I did the match. Then we have the deck. All of them here are going to be Lost Box. Of course, in parentheses, you have the variation because I use around 9 of them. Then I have the opponent's deck. Then we have the outcome, which here is either win or lose. Now that I see it, it should have been either better at 1 or 0. The prices left, that's the number of prizes I had left at the end of the match. The same with my opponent. Then I have another column that has information of whether I went first or second. Here is 0 or 1, which is what I wanted to do before with the outcome. And then I have some notes, which I'm going to explain a bit later. So I took all this data, I loaded into a Jupyter notebook, and I was like, well, let's analyze the data. Let's see what I can find. And this is the first of the interesting insight that I got from here. And here we see the ratio, the win ratio over time, or how my win ratio has evolved as I keep playing games. And here we have several decks, and they are color coded. That's the tiny color that you see there. So my first 2 matches, they were very good. I won all of them. Congratulations to me. And that's why the win ratio there is 1.0 or 100%. Then, of course, the third game I lost and the win ratio dropped to 66%. And then, of course, we can see that it went up and it has several ups and downs. Now, of those decks, the one that I would really enjoy the most is the one on green, which is called Dragonite, or the turbo version of the deck. And then we can see that at some point, maybe after 80 matches, my record started to decrease a little bit, and that's when I stopped using the deck. This is another visualization, and in this one, I have the win ratio for each of the lost deck variation. Well, as I mentioned before, the first two decks, I only used them once. However, I won those games, so the win ratio is 1.0. But then we have another one, like the baseline version, which I play 6 times. Let me increase my notes here quickly because I barely see the numbers. And then we also have the one that is the most, which is Dragonite, with around a sample size of 63% and a win ratio over 60%. Now something very similar, but this time is the win ratio against my opponent's deck. And here we can see that the first one, the win ratio is very, very high against some decks called Shenpao, Miraidon EX, or Gardevoir. By the way, it feels very funny saying these words here in a conference because that's usually the nerdy side of me. Then we have another one called Random. This is essentially like a bucket, right, for all the rest of the decks. And then we have other decks like Giratina, Lost, and Mew and Lugia. Now, the last one, the win ratio is 0.4. And yes, if you ask anyone who plays Pokemon and you ask what is the worst matchup for Lost Box, they're going to say Lugia because it's almost, I don't want to say almost impossible, but it's very hard to win against that deck. And I also see it here in my data with only 40% of matches in my favor. For the histograms. And here I wanted to know more information about how many prizes me or my opponent we had left at the beginning, at the end of matches. This in particular is a histogram of the prizes I had left at the end of matches that I lost. And we can say that the mean here is 4.5. Now, you might be asking, hey, Juan, like 4.5 is quite a high mean considering you only have 6 prizes. Yes, that's true. It means two things. That when I lost by a lot. And also, and this is not an excuse, is that sometimes if I feel like the match is not going in my favor, or if I feel like my initial hand is bad, for example, if I don't have a Battle Peppy pass, I'm just going to concede the game and be like, you know what, you won, let's go to the next one. Why? Because when you are in an official sanctioned tournament, you only have 50 minutes to finish a whole set. So if I know I'm going to lose, I'd rather just go to the next game and maybe I'll win that one. The same thing, but from my opponent perspective, here the mean is 4.1. It's a bit lower than mine, but also I realize that many opponents, they actually do not concede as much as I do. Now, for my notes, right? So beyond numbers, I also wanted to record qualitative data in the form of notes. And these notes, they contain information such as key moments, mistakes, and learning from each game. For example, one of them says forgot to use Manaphy, which is a very important card. Or too slow, like me telling me myself I was playing too slow. Or good handle of a mirror match, and that's when the opponent is playing the same deck as you. Now, given the nature of these notes, I know that analyzing them is not easy. I wanted to do something more substantial than just counting keywords, phrases, and whatnot. So I need to admit that my NLP skills are not that great, and it's been quite some time since the last time I did something important using NLP, so I had no idea where to start, right? So I just copy paste this, I went to ChatGPT, and I told GP, and that's how I call it, GP, please, could you summarize all this information, right? And GP says like, sure, yeah, of course, I'll do it. But even better than that is that something that I wasn't expecting happen, and that's that GP decided to group all my notes into 9 different categories, and I was like, whoa, this is very cool. And I just want to share like 5 of them with you. These are copy pasted directly from ChatGPT chat, so anything you see here came from GP. So let's start with the first one of them, right? The first one is concessions, and it says a significant number of your matches ended with either you or your opponent conceding, which I mentioned before. In some cases, you conceded due to mistakes or a poor start. That's right. while in others your opponent conceded possibly due to your strong play. Wow, thank you so much, chat. Then I have another one, gameplay reflections. And this one, chat is talking about those notes that I had regarding the game itself, like, oh, it was intense, or this game was very close, or I had a bad start. Then we have another section, and this one mentions specific cards and abilities. For example, Manaphy, Greninja, Drapion, those are Pokemon. Colress and Mirage Gate, those are trainer cards. Then we have another one, and this one is called Mistakes and Learning. And here I usually write about those things that I did, I know I did them wrong, and that I would like to avoid in the next game. For example, I attacked with the wrong Pokemon, classic mistake. I set the wrong energies, or I forgot to use certain abilities. And according to chat, these notes suggest that I am actively learning from my mistake and I'm looking for a way to improve my gameplay. And the last category I want to show is self-encouragement. So sometimes at the end of the game, I have some notes about how I felt about it. So I have like take it easy and slow. Do not despair. Yeah, for some reason, sometimes I get very anxious playing the game, which I know should be fun, right? And of course, always remember always to know if you'll be able to retreat. Kind of cute, right? Now for the last one, a dashboard in Google Sheets. So after I finished my second project, I was very happy. I thought it was like a very cool thing to have. I learned a lot, and yeah, it was fun to do it. However, I wanted to do something similar, but instead of collecting data, doing a data analysis, I wanted to have like a consistent tool, like a platform where I could see these values, right? I wanted some sort of dashboard, let's say. And I thought about building my own website with all this data and everything. And then it's like, no. Just use Google Sheets. Do the same thing you have here, copy paste all the values and create charts and use the formula so you can have this information without actually having to build a whole platform for doing this. And that's what I did. So I started a new Google Sheet document, and this one I was, okay, I'm gonna track data from another deck, which I'm calling Lostbox Giratina, something similar, and it contains the same information, right? So they have like the same columns that I have before, the very same data, and then I created another sheet with all these formulas, right? So I wanted to have the same thing I had before, but in a more readable way. Well, it's not that readable, but for me, it's understandable. And here, the first column has the win ratio. It's around 80%. Yes, I was quite good playing this deck at some point. Then I have the same thing that I showed before, the win ratio per opponent's deck. And we have some like Mew, Tinlu, Gengar, and Gardevoir, which is either 100% or 50. Then we have other archetypes that I always lost post-game. And then once again, we have others that I won. My sample here is only 19 games, at least at the time when I actually decided to take the screenshot. And then of these 19 games, I won 15 and lost 14. Now, there's one column that I wasn't ignoring. That one is the running win ratio. And it wasn't that easy to calculate this one, at least using those formulas in Google Sheets, or maybe it's actually impossible. And I got quite frustrated. I was like, I want this information, I have no idea how to do it. So I decided to click around the toolbar at the top of my sheet, and I saw something called app script, and I was like, what is this? This sounds like quite useful. So I click on it, and I saw a text editor screen, and here I was able to write some JavaScript, and this is what I did. So apparently you can do things like this in Google Sheets, and I didn't know about this. So I wrote one function on edit, and this one is an event that's triggered every time you edit one cell. And I would like to quickly show it to all of you, right? So first, I'm going to get the active sheet. I'm going to check if I'm using the right one. That's what I'm checking for, the name and the column. And then what I'll do is that I'm essentially going to get the cell that I have just edited. And then I'll also get all the values that I have from the first row of that column down to the edited cell. Then I'm going to iterate over all of them. I'm going to add them up, all the numbers, and then I'm going to divide them. And that's going to give me the win ratio by that time, by that cell. But if I do the same for each cell, then it's going to be sort of running win ratio. And this is how it looks like. This is the fun part of the dashboard. I have similar charts as the previous one, right? I had the prices remaining at the end of matches, the running win ratio, the opponent's prices remaining at the end of matches, and of course the win ratio per deck, which here looks way, way better than the previous one. Now, final words. What am I doing this, right? Yeah, like why am I spending my time to actually play around with Pokemon data? Well, I like to find fun ways to apply data to my life. I feel like we usually use data in our daily working life, but I also want to, apply it to myself, right? Also, to get better at Pokemon, I mean, it has become my hobby, my obsession, and of course, I want to improve as much as possible. And to learn new concept, tech, and tools. To be very honest, I didn't know about the hypergeometric distribution. I mean, what is that name? Also, using ChatGPT for this, it was quite cool. And then also to have a good excuse to use Python, which I actually don't use that much at my work, since we are mostly like a Golang team. And did it help? Probably not. Lol. I mean, I've been getting a bit better, I think, at the game, but I'm not sure if this is actually a reason why I've been improving. So, what's next? And maybe some of you could help me here, right? So, as fun as this is to do, it's very time consuming, right? I usually need to play my game, open a new screen, go into Google Sheets, enter all the data. So I was thinking that maybe some sort of software that I could use as I play, maybe like an overlay, that I could, for example, do one click every time I get one prize. That would be cool. Or even better, maybe someone have some kind of very fancy software that is actually reading my screen and storing that information somewhere. So if someone has any idea or how I could start doing an overlay on macOS, please let me know. And thank you so much. That first link is my GitHub. That's where I have the notebook and my contact information in case you would like to keep talking about data, transit safety, Pokemon, or just say hi. So thank you so much.